Sup guys, welcome to today's show. So today we are going to create an embedder. And what is an embedder? Well, sometimes when you code C, for instance, you want to include some file in your project, but you don't want to have a lot of different files. You only want the .c, for instance. So imagine you could read in a file and it will be saved like this. So int8 file is equal to, and then you have like the ASCII characters or whatever from this file. And it should be able to support ASCII files as well as binary files. And then you can just use it in your program any way you want. In several programs that I've made in the last couple of months, I have needed something like this. Usually I make some bash script on the fly or so, but today we're going to make a program out of it. And I also want to support the assembly format in case I want to include something in my assembly. So in that case, we will create a label for the file. And then we will define the bytes like these. And so on and so forth. And I want the program to have the following usage. It's going to be called EMP, by the way. No, let's call it embed. And it's going to take an identifier, like the variable name. And that's it. It's going to read from standard input, and it's going to output to standard output. And it's going to be able to take one switch, and that's -A if we want assembly. Otherwise, it's going to use the C format. And it's going to check if the file is a binary file, I think, and in that case use this format. Otherwise, if it's an ASCII file, it will just be a string. And maybe it can even do both. We'll see how it goes. All right, let's commence. I will start by creating the embed folder. And no, by the way, I'm going to use bash bs. So I get a template. And if you want access, you can go to the repo drbirch.com and install bash bs. It's my build system, or it creates make files and such. And I also have an episode how to install this and code this. It's called creating a build system or something like that. All right, so I will remove this folder and I will do bash bs embed, and this is going to be the default C. Maybe I should have a folder for each project instead. So let's recreate this embed, and let's do bash bs and C. So now I have a directory called C, which I will set to my home as usual. And we have the template. So And by the way, if you use an old GCC, you might not have. Oh, I made the wrong one. This is not C. Bash BS. Let's do embed and use the C template, and I will rename this to C, because otherwise the files will be called C.C and stuff. But if you look at the makefile, I use C2X here. And you can change this to either C23 if you use the latest GCC, or you can also have GNU 23, I think. But C2X should work on most versions, most recently new versions. All right, so let's find this directory, embed, and I will open this in editor. And this is so I can code remotely on my Linux server, and it updates when I save. All right, so what do we have? We have just the regular template, like compiling and stuff. And I define some data types and some macros for converting, typecasting. And let's also, by the way, let's change the names to the number of bytes instead. Maybe I should have a 16-bit one as well. So we do typedef, unsigned, bit int 128. And I also include Birch utils here, which you can also find in the repo. It's always available. All right, let's see if this template compiles. Yeah, maybe we should give it a name as well. And this should be called int 128. All right. So let's start at the beginning by defining the usage and the command line parameters and stuff. So we get that out of the way. I want a function which is a void function called usage, and it takes an int8 string. So void usage, int8 arg, and it will just show the usage. So we can give it a -a, and then we have the identifier. And then we exit -1. All right, so maybe we should have ability to show the help as well. All right. So let's start there. So if we have parameters, what do? We check the first parameter, see what it's containing, and I will do this very simply by doing a regular string compare. Don't remember, do I have a string compare function inside of Birch utils? Let's see. Copy print text to dotted. No, so we can create our own. Let's say this is compare, and we want it to return true if it matches. So we compare the int8 version of argv1 against -h, or if we have this other format, we will also do this. And in this case, we will just do usage and provide our argv0. All right. And if argc is 3, that means that we have 1, 2 parameters. This is no good. Let's do this instead. Okay, so in this case, we want to check if our first argument is equal to -a, and we want to have some bool for that, asm, and as is equal to false as default. But if we get this parameter, we will set as equal to true. And if we have 2 arguments and the first one is not -a, what did I do wrong? Let's see. Here we have 1. There is the second. And we need 1 more. don't we? Because this is for this, this is for this. And then we have this, and this, and this. We should only have one here. And I need to be able to spell compare. All right, so if we have 3 as argc and we don't provide this, that means we either have this -h or help, but then we should have hit the first branch. So in this case we are providing a bad usage. So we need to end. All right, and then we only have one more, and that is if argc is equal to 2. That means we have only provided the identifier. Let's see. So let's do else if here, and we make if argc is equal to 2. We need to have a variable for the identifier. So if we only have 2, then we can set our identifier to our argv1. But we should do that even if we have the -a. But in this case, we'll set it to argv2 instead. I think I got it right. It's always a little bit messy with all of these if statements. I know that there are libraries for this, but they are much too bloated, I think. Perhaps we should code our own simplistic version of that. So let's see. Let's print what we have. Asm is equal to something. And identifier is equal to this. So in this case, if asm is true, we return true, otherwise false. And here we just make a regular string out of our identifier. And we return 0. All right, let's see. This was probably the most complicated part of this project. Okay, I missed conversion. Where is it? 23. No, 18. This should be 1. What else? Increment of a Boolean expression. So we're not allowed to increment a Boolean. They keep adding those annoying things to this language. Expected declaration or statement at end of input. One of these brackets must be wrong. If argc is equal to 2, I mean more than 2, should end here. And if it's 3, do this comparison. Maybe we can remove this. So then we have this. Okay, we should have kept it for this instead. Now I think it's correct. All we need to do is make this compare function. Warning, suggest explicit braces. No, I will not do that. I don't think it's very ambiguous, is it? Maybe a little. Alright, so let's create this compare function which will compare to int date strings. So it will return a bool, we call it compare. It will take an int date star and an int date star. So we have bool compare int 8 x and int 8 y. Or maybe we should call it x's and y's. So we will have a bool for the return value, and we need to have 2 pointers. So px and py. And let's see. We don't want to compare too much. If the strings have different lengths, we don't want to overflow the memory, which means we will also need to have some kind of length function. So let's say int 16 length, and we have an int 8 x's. No, let's call it str in this case because we have only one. Int 16 n, And we need a pointer, int 8p. Make a for loop where we set p is equal to str, n is equal to 0. And we go as long as we have a p. And at each iteration we increase p and we increase n. And that's it. We return n. And let's not forget to create the signature. So int 16 length, and we have an int 8 star. Alright, so now that we have a length, we can use it right here. Let's do something like this. First, n is equal to the length of x's. Then we set let's use 2 instead, so we show our intent a little better. So let's do a nx and an ny, where nx is equal to the length of x's and ny is equal to the length of y's. And if nx is not equal to ny, if there are different lengths, then we can return false immediately. Otherwise, we set our n equal to min, max, nx, and y. So or min, doesn't matter, they are the same. So let's set it to nx. Alright, so let's do this loop. So from the beginning we set maybe we don't need to do it like this. We do it here instead. So n is equal to nx. And let's see. Px is equal to x's, py is equal to y's, and the return value is equal to false for now. Or maybe we should default to true, maybe that's easier. And at each iteration we're going to increase px and py, and we're going to decrease n. And we're going to loop as long as we have an n. So we are only comparing the correct number of bytes. Alright, and what do we do at each iteration? Well, we check that px is equal to py, or not equal. And if it's not equal, we will set return to false and we break. Otherwise we continue through the loop and then we have our return value. I think that is right. Let's try if compare ABC and ABC. Too few argument. Oh, so there is the parentheses trouble. Let's see, 53. Because here we have this, and here we have that. This should be the same function application. True, and if we have ACC, false, and if we have different length, false. All right, so everything works this far. So what's next? Now we have all our different parameters. So now we want to first output the header. The header being the identifier basically. So we want to have something like unsigned char ABC is equal to, yeah, let's keep this on one line like this. So maybe we can put it in our own function. So we do print header, and we need to give it the identifier, but also if it should be ASM or not. Maybe we should create this so we can support, or at least be able to support, more formats, so we don't lock ourselves to just one. So let's create an enum. So we'll do enum e language, and C is equal to 0, ASM is equal to 1. So we'll only have these for now, but now it will be easier to add more later on. So enum e language should be language, like so. And this function print header will take an int 8 star for the identifier, and it'll take a language. So remove this asm and instead create language lang. Lang is equal to C by default. And in this case, we will set lang is equal to asm. So now we can create this thing. Void print header. Maybe we should abbreviate this to HDR. And it takes an identifier and language lang. And we can make this real simple. We'll just do a printf. Let's do a switch. So we switch on the language, and we have a case for C, we have a case for ASM, and we have a default, which is the same as C. So let's switch these up a little bit. And then we can just put the printf at each location. So if we use ASM, we will just define a label for this identifier. So it'll be the identifier followed by a colon. And that's it. And in case of C, we want to do unsigned char, the name of the identifier is equal to this. Identifier might be uninitialized. I don't think so. Can we do, but I don't think that'll work, no. All those annoying warnings. Let's just do this. Identifier is equal to 0. All right. Right, we didn't have a usage case. That's why it complained. We didn't have a usage case for else. No, it still complains. Identifier is equal to 0. Okay. And if we do like this, or if we do this, and this looks good. So if we do embed, and we say variable k, didn't like that. So in this case, our argc, right. We need to copy this thing, put it here, I guess. And it should not be else if, should it? Let's see. Maybe we can do this. And we set this to if. And we set this to else if. Right, looks good. And if we do it as assembly, we just get this. Okay. Let's just double check real quick. Yeah. So the only thing left is printing the contents of the file or the standard input. So we will have a print body without parameters, I guess. No, we need to know the language. So void print body language. And I guess we want to have a print character as well, or not print character. We should return it. So let's have an int 8. What should we call this? Convert. And we'll take one single character, so an int 8 without the star. So this conversion function will take a character, either it's an ASCII character or it's not, and we will convert it into one of these strings. So This makes our print body function real simple. Let's create an int 32. I don't think we will need more than 4 gigabytes of files. So this will be our n. And let's also have a signed int ret. And as long as we will, so let's do ret is equal to read. We need to have a buffer. So let's say int 8 buff 2. And let's initialize this like this. Buff is equal to buff plus 1 is equal to 0. So we will read into our buffer, and we read from standard input, which is 0, and I want to read 1 byte. And if this is equal to 1, we will keep looping. And if it's not, we will break. And when we have read 1 character, we want to print it to the screen. So let's see. We want to increase this n. And let's create an intermediate variable. So this will be our character. So we set C equal to convert. And we will give it the buffer, or the first byte in buffer. And we also need to know the language when we convert. So now we should get a string back. If we don't, something has gone terribly wrong. Maybe we can assert that we have a C. So now we want to print this to the screen. So let's just do write to standard in, standard out. And we want to print over C as a regular string. And we need to take the length of our C. Alright, so we write it to the screen, but we don't want to have like 10,000 characters on one line. Let's limit it to, I don't know, 16 perhaps, or 8. Let's do 16. Which means that if n is divisible by 16, in that case we want to write a new line and a tab. Yeah. And when we are done, let's see. Yeah, that's right. And when we are done, we can have a switch on the language. And if we use C, we want to write this and a new line. And if we have assembly, we don't need to do much of anything. We can just write a new line. Okay. I think that's pretty much it. We want to clean out this buffer again. I think that's it. So then we return. So the only thing left basically is our conversion function. So we're going to return an int8 string, and this will be convert, and it takes an int8 character and the language. So this will only be a switch, I guess, on the language. And we have a case for C, which is our default, and we'll have one for ASM. Maybe we need to change the print header. Let's see. Because we need to have a tab right here, and this, because we need to have it inside of quotes, which means we need to do the same here. Like so. So if we have assembly, we want to return, let's see, maybe we can do it like this. So we have an int 8 ret, int 8 ret 8. We start by cleaning it out. So basically we'll just use the birch utils thing for that. So we 0 our ret 8 bytes. And then we can do snprintf. That is like printf, but into a variable. So we give it our ret as a char string, and we give it a maximum size of 7, let's say, because let's see how big this can be. 0xab. This is maximum, so 1, 2, 3, 4 in case of assembly, and 1, 2, 3, 4. So we'll print this as a 2-digit byte string or hexadecimal, and in front of it we want the 0x, and this should be a char C. And in case of this, we'll do the same with the snprintf. Seven, and this will be a backslash and an X. And then we have the hexadecimal numbers. So 0 to HHX. The double H means that it's an 8-bit variable. And when we do it like this, we will print the characters as hex no matter what. Let's do it like that. It's not necessary to do it in another way. And let's make our lives easy by making this a static variable so we can return it. And I think that's pretty much it. Maybe some troubleshooting, but yeah. Lang. Yeah, it should be language. And I need to learn how to spell language. Case label does not reduce to an integer constant. 62. Language. That's weird. And why does it only care about the C? And I did the same with the ASM, right? Maybe I can't name it C. I have another C right here. Okay, that is not good. We need to change this as well. CH, cert, CH. And we need to add this quote to our header as well. Okay, I have it. All right. Return. Let's put the N right here. N may be uninitialized. Well, yeah. Okay, it compiles. That's good. So what should we test it on? We can test it on our make file, perhaps. Right, that's not the format. So let's say this is our variable and we take the makefile like this. Okay. That's a little bit too weird. By the way, let's not make this static. Or we can make it static, by the way, but let's remove the assert because this will never return 0. So we read a byte. And we try to convert it. Right, we'd never change these to CH. It's tricky when you have a collision of variables. Okay, so now it's the correct number of bytes and probably the right values as well. But why does it always create a new line like this? Because n is 0 and we increase it each time. And if it's divisible by 16, we should be doing this because it returns 0 in this case. So we had it reversed. Okay, this is what I was looking for. The first line though didn't look good enough. So let's update our print header and new line, tab, and this. Maybe we need to flush as well. Alright, that's better. And how does it look if we want assembly output? Forgot one thing. Let's see. If lang is equal to asm, and n is not 0. So every time but the first, we want to write a comma. And we don't want to do that if we have just written a new line either. Those trailing commas are really difficult to do in a good way, because we don't know when the file ends. So we can check for that and add the comma. But if we just do it like this, and to standard out, we print a comma. How does it look then? Didn't trigger. If lang is equal to asm and n. It's weird that it doesn't trigger. And we need to update the header because I forgot one thing. I do want the tabs right here. And we also need to have db in this case. And we need to have this here as well. So it'll be a new line, and it'll be a tab and another db. So 1, 2, 3, 4, 5, 6. Okay. Oh, wrong place. This is just the end of everything. We need this to happen at every iteration. Maybe we should do a switch inside of here too to make this a little better. So if we have C, or the default, we'll do one thing. If we have asm, we'll do another. So if we have C, we want to do this. And for asm, we can do n is equal to 1 in this case, or not equal to 1. Let's see. Maybe we can do this. And if n is more than 1, we want to do this. Otherwise, we want to do the same, but well, let's cheat with printf. So in this case, we want to print a comma. No, this is not good. If n is more than 1, we want to print the comma. And let's not do an else. Let's just do this anyway. So we print the comma if we're not at 0. And then we print our character. And if we run this C function, we want to still print the character. And then we want to print this new line thing. Possibly. And in case of assembly, if we're at number 16, what we don't want to do then, we still want to print something. We want the new line. And we want the tab, and then db, and a space. So 1, 2, 3, 4, 5. Oh, I need to see how this looks now, because I've change stuff all over. There's always problems with these trailing commas. Okay, the comma seems to almost work. But this is happening before the character. So we should probably do n+1. We need to use the right symbol. Okay, that looks pretty good. But why are we one short here? Okay, and when we print the header, by the way, in the ASM case, let's do a double space right here. Why, you ask? Because we want it aligned like this. All right, this looks pretty correct to me. And what if we don't use the A? And this looks correct as well. No, we need to have one of these quotes by the end as well. So before the new line. All right, and at the end as well. There we go. Pretty nice. I'm going to use this when I code, so I will copy this thing, strip, embed, and let's just see, I don't have any other embed, right? So I will copy this to user bin, and now I can embed whenever I want. Pretty nice. So if you like this episode, please like and subscribe. And if you want to know when the sequel to this drops, you can hit the bell icon to get a notification. And thanks for watching. Thanks for today.